Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. Right now, as you watch this, two spacecraft launched in 1977, built with technology less powerful than the phone in your pocket, are still operating, still transmitting data back to Earth, and have traveled further from the Sun than any human-made objects in history. One of them has now crossed into interstellar space, the void between star systems, making it the first human-made object ever to leave our solar system entirely. They were launched 47 years ago. They're still going, and the signals they send back home, traveling at the speed of light, now take over 22 hours to reach us. This is the story of the Voyager missions, what they found, what they're still finding, and why two spacecraft the size of a small car launched almost half a century ago represent one of the most extraordinary achievements in the entire history of human exploration. And in our next episode, we're getting into the conspiracy theories that have grown up around them, including claims about what Voyager has actually encountered out there that NASA isn't telling us about. Stick around for that one. The Voyager missions wouldn't have been possible without a cosmic coincidence that comes around only once every 176 years. In the late 1970s, the outer planets, Jupiter, Saturn, Uranus, and Neptune, were positioned in an alignment that allowed a single spacecraft to visit all four of them in sequence, using each planet's gravity as a free speed boost to reach the next one. This technique, called a gravity assist or gravitational slingshot, works by flying a spacecraft close to a massive planet and using the planet's gravitational pull to bend the spacecraft's trajectory and transfer some of the planet's orbital energy to the spacecraft, essentially stealing a tiny, immeasurable amount of the planet's momentum to accelerate the spacecraft toward its next target. The planet loses an infinitesimally small amount of orbital energy in the process, unmeasurable, completely negligible, and the spacecraft gains enough velocity to reach destinations that would otherwise require far more fuel than any rocket of that era could carry. Without this planetary alignment and the gravity assist technique, reaching Neptune would have required decades of additional travel time, and the missions as we know them simply wouldn't have been feasible. NASA scientist Gary Flandreau identified this alignment opportunity in 1964, giving the agency just over a decade to design, build, and launch spacecraft capable of taking advantage of it before the window closed. The result was one of the most scientifically productive space missions ever flown. Like, subscribe, and hype the video, because what Voyager found at each planet completely rewrote our understanding of the outer solar system. When Voyager 1 made its closest approach to Jupiter in March of 1979, it returned images that transformed our understanding of the Jovian system from a small set of blurry telescopic observations into a detailed portrait of one of the most complex and dynamic environments in the solar system. The Great Red Spot, known to astronomers for centuries as a mysterious feature of Jupiter's visible disk, was revealed as an enormously complex, continuously churning storm system with detailed spiral structure visible for the first time. The cloud bands of Jupiter's atmosphere showed intricate turbulence, wave patterns, and interaction between different layers that gave atmospheric scientists years of data to analyze. But the most shocking discovery at Jupiter had nothing to do with the planet itself. It was one of its moons. As Voyager 1 flew past Io, one of Jupiter's 4 large Galilean moons, its cameras captured something nobody had expected: active volcanic eruptions. Enormous plumes of volcanic material were shooting hundreds of miles above Io's surface in real time, captured in photographs that represented the first confirmed active volcanism ever observed anywhere in the solar system other than Earth. Io turned out to be the most volcanically active body in the entire solar system, its interior constantly churned by tidal heating from Jupiter's enormous gravitational pull. Voyager also returned the first detailed images of Europa's icy surface, revealing a cracked, smooth terrain suggesting that liquid water might exist beneath the ice, a finding that laid the groundwork for Europa's current status as one of the most astrobiologically interesting worlds in our solar system. Saturn was the crown jewel of the Voyager mission's early encounters, and what the spacecraft found there exceeded expectations dramatically. The ring system, seen from Earth as a broad, smooth structure, was revealed by Voyager as an extraordinarily complex, layered architecture of thousands of individual ringlets, each one a distinct band of material orbiting Saturn at a slightly different distance, with gaps, waves, and braided structures visible throughout. One of the most surprising features was the discovery of shepherd moons, tiny satellites whose gravitational influence was maintaining the sharp edges of certain rings by corralling the ring particles, preventing them from spreading outward. The rings turned out to be a dynamic, gravitationally sculpted system rather than the static, simple structure they had appeared from Earth. Triton, Saturn's largest moon, had long intrigued astronomers because it was known to have a thick atmosphere, the only moon in the solar system with one substantial enough to matter. Voyager's images were frustrating in one sense. Triton's dense, orange atmospheric haze completely obscured the surface, preventing any direct imaging of the ground below. But the atmospheric composition measurements Voyager made of Triton, revealing a nitrogen-rich atmosphere with complex organic chemistry, established Triton as one of the most chemically interesting worlds in the solar system, eventually prompting the dedicated Cassini-Huygens mission decades later. Like, subscribe, and hype the video, and let's get to the discoveries that made Voyager 2 uniquely historic. Voyager 2 holds a distinction no other spacecraft in history shares, and none is currently planned to match. It is the only spacecraft to have visited Uranus and Neptune, the two outermost planets, and the only spacecraft to have conducted close-up observations of all four outer planets. The Uranus encounter in January 1986 revealed a planet that looked almost disappointingly featureless from a distance, a pale, uniform blue-green sphere with almost none of the dramatic atmospheric activity visible on Jupiter or Saturn. But Uranus's moons proved far more interesting than the planet itself. Miranda, one of Uranus's small inner moons, showed one of the most geologically bizarre surfaces ever photographed, a chaotic patchwork of completely different terrain types, sitting directly adjacent to each other, as if the moon had been catastrophically shattered and reassembled. One feature on Miranda, a cliff called Verona Rupes, drops roughly 20 kilometers straight down, making it the tallest known cliff in the entire solar system. Neptune, visited by Voyager 2 in August 1989, was far more visually dramatic than its planetary twin Uranus, a deep, vivid blue with visible storm systems including the Great Dark Spot, a storm roughly Earth-sized that has since disappeared. And Triton, Neptune's largest moon orbiting backward, which we covered in our Neptune episode, was revealed as a geologically active world with nitrogen geysers erupting from its surface, dark streaks left across the pale terrain by material carried downwind from the eruptions. In 2012, after 35 years of continuous travel, Voyager 1 crossed the heliopause, the boundary where the Sun's solar wind ends and the interstellar medium begins, becoming the first human-made object ever confirmed to have entered interstellar space. Voyager 2 followed in 2018. The crossing of the heliopause wasn't a dramatic visual event. There's nothing to see in that region of space, no line marked in the darkness. But Voyager's instruments detected the change unmistakably. The solar wind particles surrounding the spacecraft dropped dramatically, while the density of particles from interstellar space increased, confirming that the spacecraft had left the Sun's direct influence and entered the space between the stars. The data Voyager is returning from interstellar space is scientifically extraordinary precisely because no other instrument has ever been there. Measurements of the magnetic field direction, cosmic ray intensity, and plasma density in true interstellar space are giving scientists their first direct observations of an environment they had previously only been able to model theoretically. And Voyager is still transmitting, its nuclear power sources slowly fading, expected to fall below the minimum operating threshold sometime in the late 2020s, after which the spacecraft will continue silently into the galaxy forever. In 1990, as Voyager 1 was leaving the solar system, Carl Sagan persuaded NASA to turn the spacecraft's camera back toward the inner solar system for one final photograph. The resulting image showed Earth as a pale blue dot, a tiny, barely visible point of light suspended in a sunbeam, lost in the vast darkness of space. It is one of the most humbling photographs ever taken, and it exists because a spacecraft launched in 1977 was still functional and still listening to commands from Earth 13 years later. But here's what most people don't know. What Voyager found as it crossed into interstellar space raised questions that NASA has been very careful about how it discusses publicly. In our next episode, we're getting into exactly what changed in Voyager's data as it crossed the heliopause, and the theories, some of them from credentialed researchers, about what those anomalies might actually mean. Stick around for that one. Like, subscribe, and hype the video so you don't miss part 2, and let me know in the comments what you think is the most extraordinary thing Voyager discovered. I'll see you in the next one.